Full field models are usually fairly large and include heterogeneities in at least some of the geological parameters. That means that they can be cumbersome to work with in certain ways. Consequently, we recommend that before building a full field model, you build a single well or pattern model that can act as a model for the larger model. As we have seen, the smaller model can be very effective to explore sensitivities into reservoir or production parameters where it would take much more time to use the complicated full field model. But eventually we want to see how wells interact with other wells in terms of heterogeneities, faults, or other conditions that are not incorporated into the simpler model. Let's see how easy it is to start with the single well model built earlier and build a complex full field model with multiple wells, faults, and heterogeneities in most parameters. So we do not wipe out the file we've already built. We'll first save as a new file name. Next, we need to tell Merlin that this is a general or full field model rather than a pattern model. When we built our pattern model, we had to treat the edge cells in a special way. Transmissibilities and porosities must be modified, and wells on the boundary must be handled in a special way. With most simulators, this is left up to you, and it is a very error-prone process. Merlin handled all of these details for us, so we didn't have to worry about them. Now Merlin needs to know what to do about these special conditions. If we were building a special pattern model, we would want to keep them. In this case, we're building a full field model which does not require them, so we will clear them out. Next, we specify the number of cells in the model. We'll be working with the Apprentice files that were developed in the Apprentice demo, which used a 25 by 25 aerial grid. We only had one set of maps, so we'll start with one layer in Merlin. This completes the setup of the model. In the next segment, we'll see how to import maps into Merlin.